Okay, just as a general review or maybe new to you roof terminology, gable roofs are basically the upside down V. So that would be a gable roof, that would be a gable roof, this would be a gable roof, that would be a gable roof. This is not a gable roof because this is more of a gambrel roof. It's not the typical upside down V. So it's just basically they frame it up to the ridge and back down. Another system is the hip roof system. Basically it's typically a triangle and a trapezoid like this. So those are considered hips, a ridge, a hip there. So that's considered a hip roof. This is actually a bay window, and these are dormers with gable roofs there. But the hip roof is basically slanted like this as opposed to the gable. So this is slanted in both directions where the gable is only slanted in the one direction. So that would be a hip line, that's a valley line, that's a ridge line. Then there's also things known as a shed roof. It's a one directional roof. Dormers or anything that pretty much sits on the roof. This is more typical of a dormer with an opening in it. This could be argued either way. I guess those are dormers because it's sitting on the roof below. I'm not quite sure that really technically qualifies, but maybe it does. I don't like the way this is put together because this is implying that you're looking at rafters. This is a truss. A truss is different than a conventional frame system. So truss is pre-manufactured and pre-engineered and pre-built and delivered to the job site. So not technically a rafter, it's more of a truss, but the purlins up here are basically holding up the roof. And you can also have purlin bracing that could be braced back down to break the span of the rafters. Roof systems use what's known as a roof slope or a roof pitch. The 12 is always the horizontal. The units have to be the same. This would be a 3 and 12 roof. So 3 inches. So for every 12 inches horizontally, the roof rises 3 inches. And this, overhangs is basically how far out it is from the overhang to the edge of the roof out here. It's just basic terminology. You kind of saw some of this in the detail fascia that we had before. This doesn't have a trim board on it. It did have this has OSB, similar to plywood, oriented strand board. It's a sheathing. They don't have the 1x2 here, but they do have the fascia board out here. And if you had a soffit down below, you would have this board. And then you have the double top plate here. And this is called a rafter. Again, I don't like the way that's called out. If it's a truss, it's a truss. If it's a rafter, it's a rafter. You can have a tail on the truss, or you can have a rafter tail. But the rafters are individual pieces of wood. Trusses are pre-engineered and delivered to the job site. Here they are showing the trim and the fascia, and this is tongue and groove here. And there are different ways, like we talked about before, that you can do this. This is that plumb edge that was on the first test, and we talked about a little bit about a raked edge. They're calling it a square edge here, which is basically what it is, but they usually call it a rake here. So just some general roof terminology. In plan, when you're doing the roof, you're looking at a two-dimensional object. A three-dimensional object in a 2D view. So you have to learn to read which lines are doing what, and it takes a while to learn how to do that. But essentially, we're just going to go through some simple roofs here. So here's our roof pitch, 8 and 12 for every 12 feet horizontal, 8 feet vertically, which I've come over here. So the blue line's representing the edge of the house, the white line's representing the roof overhang. So the roof overhang or the lines on the roof correspond with the elevations. But if it's a single pitched roof, which means it's front to back and side to side, the same pitch in both directions. In other words, 812 front to back and 812 side to side. If it's the same pitch, you're always going to have a 45-degree line on the roof plan. So what that means is I would use F10, but if I use F10, it's it's going to turn off the video, so I'm not going to do that. Anyway, so since I've got an equal distance in both directions here, my 45-degree line is automatic if I connect these two. But the line is always 45 degrees on the roof plan. So in a square plan, you're always going to end up, if it's at the same roof pitch, coming to a point, basically a pyramid. But what you see in elevation is basically this. Alright, so if you make it longer on one side, this way, then you get a ridge up here, a side-to-side ridge. And then the hip roofs are at both ends. Well, the whole thing is a hip roof in this particular case. But you have what is known as a hip rafter here and a hip rafter there. And then you would have a ridge here. The roof plan does correspond with the elevation as far as dropping down lines orthographically. But the angles don't have to correspond. Always 45 on the roof plan if it's the single pitch all the way around. And just like over here, regardless of how high or how low this roof is, the elevation distances don't change, nor does the roof plan. If it's front to back, then of course it goes in the other direction. And the elevation itself really doesn't change from what we had in the first one. So that's a front to back ridge in this case. So the elevations are very similar here, but they're two different things in plan and the roof plan. Here, if you have an L shape where one side is wider than the other and they're at the same roof pitch, the one with the wider section is going to have a higher ridge than the other section. Plus it turns, so you have to have some way to get the rain off the roof basically, and it's automatic because it creates a valley line. Not sure that's the right width, but we'll try that to begin with. Alright, so I'm going to realign those. All right. So there's a couple of things missing in this one. So we've got the hip roof here, the ridge line comes over, but this part of the roof is sloping up this way, this part of the roof is sloping up that way. So it's very similar to what was happening over here when we extended it that way. You would have to have a hip line there. But you can see that this ridge line is not meeting up with it. That's because this ridge is technically higher. Well, it is higher. It's not just technically. It's higher than this ridge. So you would need to get back down to the ridge on the other side. Which leaves us one more thing. This is all turning okay, but you can't have this roof going this direction and this roof going that direction and not have somewhere to turn at. So that's where the valley line comes in. And the valley line where the rain drains to looks exactly the same as the hip line. It's the same 45-degree angle. So you kind of have to learn to read what the roof is doing, where the ridge line is, where the valley lines are. Basically, if it's like this, the rain's going to be draining to it, and if it's like that, the rain's going to be draining off the roof the other direction. But in elevation from the front, because you don't see this part back here, you would see the same thing here as you would over there. This is lower in the back, so the only thing you see up front is what we saw in this elevation over here. And again, if it's all single pitched roof, it's always a 45, which means whatever the roof pitch is, it's not going to match up that way as far as angle goes. But it does match up geometrically because you're looking down on the roof, not at it in elevation. And if he goes the other direction, then of course, as you might expect, he does some opposite things from what he does there. So we could copy the hip lines over to get started, put our ridge line here. We're also going to have hip lines here. Mirror. Have to have ortho on when you're doing this or it can really get confusing. Plus it won't work correctly. So we'll have a valley line and a ridge line. Didn't get it. Copy. So that's a valley line there because it's got to turn. It's got to come up to a ridge. So it really can't do that, so it's got to turn back the other direction. Can't do that either, so we gotta have a hip line back there because it's a 90-degree turn back there. So in this particular case, because this is visible, even though it's further back, this would look different because you would see all of it in this case. And where the overhangs and where the hip lines come together, you can always project from. And if you can see where the hip is intersecting the ridge line here, you will also be able to connect that in the elevation as well. So that's a single pitched roof. So they're 45-degree angles. They're fairly straightforward, a lot more straightforward than dual pitch roofs, which is one pitch in one direction and one pitch in the other. If you have a gable roof like the upside down V, instead of having a hip roof like this, what would happen here is that it would just run out straight. And all you see of that upside down V is a straight line because this is rising from this point up to the ridge and then going back down. So that's considered a gable roof there. These are hip roofs. If you had the condition to where you had a dual pitch, maybe a 612 and an 812 roof, side to side, one pitch, back, front to back, another pitch, then you have to determine what the roof pitch is. And essentially you do that, or you can do that, by if this is the 812 roof, then you come off 8 feet this way on that roof, and if this is a 612 roof, you come back 6 feet that way on that roof, and then you connect the dots, and then that's your diagonal. It's basically a ratio of one pitch to the other. So in this particular case, looks like I'm going to copy this over. And you can see there are other ways to do roofs. You can make it the standard overhang the same distance all the way around, even in different pitches, but if you do that, then you've got to have a raised plate for part of the framing is higher than the rest of it, depending on which direction you're going in. So, but you can adjust the framing in the overhangs to where it comes over the corner here by just adjusting the overhangs and the diagonal. So in this particular case, you know, where it was a pyramid before, because the pitches are now different, you're actually going to have a front to back ridge on this one. Same house, different roof pitches. The first one had an 812 all the way around. This particular one has 6 to 12 from side to side and 812 front to back. So this is what we had with a single pitch, just a pyramid. This is what you get when you have the dual pitch. And then it just, you know, depending on, and it's because at one pitch you're going to hit the ridge higher, quicker than you would in the other direction. So the lower pitch is going to take longer to hit the ridge than the higher pitch. So this being the 812, it hits the ridge quicker than the 612. You get the idea. So let's just move this over to here. Now the angle stays the same, the ratio stays the same, so you can mirror it as long as your ortho's on. So that's somewhat similar, except in this case, because the roof pitches are different and we have a dual pitched roof, one pitch in one direction and one pitch in the other direction, the ridge for this one actually gets shorter, and it's wider here and shorter there. And that's just by changing the roof pitches. So over here would be something similar to what we had in the beginning here. Of course, this would move all the way back. Again, the front elevation looks very similar from this one to that one because nothing really changed. Here, I've got kind of an L shape, but it starts to get a little more tricky with the dual pitch. Go ahead and copy this over. So I'm going to move this on over. So this turns at a 90 degree. There would have to be a valley line there. This is turning the other direction, so that would be a hip line. So out here, you would have a hip line on the other side. You would have a hip line over here on the other side. That ridge won't be where it's shown right now. It would be over here, centered between the two. Alright, so let's kind of connect the dots. Alright, this is one of those cases where it's very close to meeting, but it doesn't technically meet. So that actually hits that ridge there and would have to come back down as a hip into the valley line and the ridge on the other side. So each one of these is that's going this direction, this is going up that direction, this is going this direction, that's going to the ridge that way, this is coming up to here, that's coming up to there, and we end up with a tiny point that's higher than that ridge, but you don't really see it from the front because that ridge line is actually behind where this is. And then as the last example, we'll look at this one. All right, I'm going to move this on back to the corner. Hip line on the other side. Comes up to a ridge line, all sloping up to the ridge. That ridge is not in the right place, so let's find out where it goes. So it would be more over here in the center. Alright, so let's get the other hip, actually valley line, because that's turning an inside 90. So that would be a valley line. So if the rain was here, it'd be draining off this way, but up here it actually drained to the valley and then off the roof. So in this case, I would do that all one plane. So back in the front elevation, kind of like we saw before, we had this section. And then we would see what's further back. And this comes across, and if I drew that correctly where that cross is there, this should align with this point in the roof plan. So they are coordinated with each other, but the actual roof pitch and the elevation has nothing to do with the roof angle on the roof plan, other than the fact that it's in a ratio. So they do relate to each other, but don't get confused about how they relate. In other words, if you have an 812 or a 612 pitch, you don't draw that on the roof plan. The roof plan is purely based on the ratio of one pitch to the other, or a 45-degree line if it's the same single pitch. And it can get more complicated with raised plates and different roof pitches, but that's the basics of how things work in roofs. So for our roof, since we already know that all the overhangs are 2 feet, what we want to do is follow the perimeter outline of the frame wall and offset the roof line 2 feet from there. Wrong one. Okay, so I'm going back here. So what I'm going to do to begin with is, you created the roof layers, and so there are a few roof layers here. The outline is actually the edge of the roof. The hidden line is actually representing the perimeter frame wall line for both the second and first floors. So we'll draw the second floor first. So we'll set that as current. Basically, you're basically drawing over the top of the frame. So it might actually be easier to maybe only see that layer or those 2 layers. So what I'm going to do that is just freeze everything. And right now there's nothing on A roof hidden. But I'm going to come back to A1 wall frame, which I'm not quite there. And I'm also going to lock it so I don't change it. No, let's do A2 wall frame first. It'll be easier. A2 wall frame, lock. Okay, so, all right, hard to see, but basically what you want to do on A roof hidden is draw a line right over the top of the perimeter of the second floor wall there. Alright, so I'm going to go back and freeze the A2 wall frame. Unlock it again. So we're only seeing basically the perimeter frame wall for the second floor, but all the overhangs are 2 feet out, and it's going to go on the A roof outline layer. I got a thought before I can set it as current. Come on, set the current for me. There we go. All right, so I'm going to offset. It's going to be 2 feet. I wonder if it's going to offset to the layer or not. We'll find out. Nope. All right, I'm going to back up a step. So offset, layer, current, 2 feet. Let's try this again. All right, so that's what we want to see. So we're creating the overhangs 2 feet out from the framing, which would be there long before any exterior materials were there. Then we're going to come back and fillet those lines together. It's either this or type in F. I want to type in M after that so you can keep going with the command. We're basically creating the roof for the second floor. So our particular plan has mostly gable roofs on it. Not so, there are a couple of hips, but mostly it's gables. So this is a gable, that's a gable, this is a gable, that's a gable, that's a gable. There's a hip down here at the porch on front and back, but most of these roofs are gable roofs. This gable's in front of that one. The ridge is always halfway in between. At least in this plan it is, because we don't have any raised plates. So one of the things we can do is just draw, to begin with, is just draw from the midpoint on these, and then we'll come back and clean it up after the fact. So starting from the midpoint in, make sure your ortho is on. So this gable here comes into the valley lines that are in the middle here. They're at a 45 degree. Since our overhangs are the same in both directions, it's going to automatically create a 45 line. That's geometry rules. Basically, if you have equal sides of a triangle, then you're going to have a 45 degree angle. So you would just fillet that together. And then you could either do the same thing on the other side, or you could just mirror that. All right. So now we've got a bigger roof behind the larger roof, but what determines whether that roof is are the frame walls here. So basically the edge of that roof back here is there for the larger roof. So this is going to turn like that, and the same thing on the other side. All right. Now, looking at the elevation, this is not really a gable on this side. I'll bring the elevation back over. I drew a line from the midpoint, but this really doesn't do that there. This gable runs all the way through, and you have the one in the front and the one in the back. So there's no gable right there. So in the roof plan, this line doesn't belong. It was only there to get it started in case that was a gable. All right, so, but now this is that bigger gable. So the midpoint is, it's going to be between this line and that line. So draw a construction line from one side to the other, and then find the midpoint. Then erase your construction line and extend it in both directions. Because this is the smaller gable in front of the larger gable, and we have the same thing happening in the back. In those gables, did I close that? You can see the wall continues, basically covers up to where basically the wall that's above the gable ends at the ridge here. I mean, the wall is all there, but this wall kind of ends there. So in plan, you would take the A roof hidden, and then behind that ridge there, this line would continue on over. It's basically representing the wall that's up there in the gable. And you would do the same thing on the other side. But it does end there at the gable, so you fill it. when one roof goes under another roof, you need to show it going underneath. So that's just another hidden line. All that's representing is the fact that this gable is below, the edge of this gable is below the upper one. And it's going to be the same on both sides here. One other thing we need to add to the upper roof is where the chimney is located. It's based on where that vent is out of that wall at the second floor. So if we come back and to the A2 wall frame again and the A2 plumbing, the very midpoint of this wall is where the chimney is located. It's a 3x2 chimney. It's on the same layer as what we as the outline layer. I'm just going to draw out here in space to begin with. So it's 3 feet this way, 2 feet this way, not 21, 2 feet, 3 feet this way. Apparently I didn't do that right. 3 feet this way, okay, 2 feet that way. Anyway, it's 3 feet by 2 feet. Then I would draw a diagonal, just like we did on the floor plan. Fit the midpoint right there in the center of that circle. If you've got the center of that circle, should be exactly in the midpoint of that rectangle anyway. If you don't have it there, it's in the wrong place. So the chimney is centered over that wall, over the plumbing. And then you have what's known as a cricket or a saddle. Sometimes in this area it's called a saddle. A lot of areas they call it cricket. It's sort of interchangeable. Basically, it's a small little roof behind the chimney that diverts the water around. Otherwise, the water would be draining from the ridge down this direction. It would trap behind the chimney and would rot the wood. So they build a small little tiny chimney. I mean, it's a little roof behind the chimney there, and it's at the same angle as the rest of the roof, the 45. So you could just take, these angles here and extend them once you get them over. And then trim it out. And then since it's diverting the water, it has a small itty bitty ridge right there. So the water goes around it instead of trapping behind it. So we got the second floor. Now we need to do the first floor. Same process, but it's under some of the second floor and under some of the second floor roofs. But we still start out by drawing a roof hidden over the top of the first floor wall frame. So A1 wall frame, I would lock it so you don't change it. And just the outside exterior perimeter frame walls where you need to draw it. So it actually is a little bit further out here. You don't need to draw over what you've already drawn. It's just because this is actually below and the second floor is sitting over the first floor there. So one place is here. It has a lower roof. One place is here. It has a lower roof at the first floor. Also, you need to locate where the columns are at the covered patio. Locate where the utility, which starts here, it's partially below the second floor, and the garage, which is completely below the second floor. Then we've got the front porch columns. So if you look at this west elevation, there's basically a shed roof here, and there's a gable that's the same width as the upper gable, but it's projecting out further. So that's at the west side. So very similar to what we drew for the second floor for that side. Basically, we got 2 feet out still. So I'm going to reset this to a roof outline. Offset it to 2 feet that we had. And it's directly beneath that other roof. So basically, I'm going to offset. Where's my offset? There it is. Offset 2 feet, both sides again. Now, in reality, the way the elevations are drawn, this actually runs underneath that, but I don't see that we need a double line there, so I'm just going to drag this back. We can pick that up in the elevation. Fill this together, and we're still going to have a ridge, but it's lower than the upper ridge. It's in the same location in the roof plan, but this is that lower gable, and that's the upper gable. Then we had that shed roof back here. We're still using a 2-foot overhang in both directions. Well, a lot of people will use a foot for a gable, but we're using 2 feet offset. And so it's here and there. I don't really need the first floor on anymore, so I'm going to freeze that layer. All right. In this particular case, this line's already there. The line would be coming underneath it there, and it actually does do that and come out. You don't really necessarily, sometimes when you put multiple lines in the same place, they get blotchy, so it's probably better practice not to do that, even if it's technically there. But it continues on up, and if you look at that elevation, this one, you can see that this edge actually, it goes beyond this edge. They do that so if they cut it off right here, it's a bad flashing point. A lot of times it gets a leak, so they like to kind of wrap the roof around maybe a foot so they can flash it. The flashing means to drain the water better with the metal. So it comes actually in a foot. So I'm going to offset 12 inches. Here. I'm going to trim that back. That looks like the same width as the wall. Okay, so I'm just going to match properties. That lower roof's actually doing this, coming up, and then it stops right there. That other line's the upper roof coming up across there. So you're kind of getting multiple meanings depending on what you're looking at. Over here, this roof is going underneath the other roof. So you would draw the hidden line there. Back here at the back porch, we still have 2-foot overhangs, but it's actually a hip roof back there. These are the hip lines. Gable above, but that's the hip roof below. And they're all, the porch roofs are all 2 and 12 roofs, and the main roof's all 8 and 12. So since this roof is all the same, it's going to be a 45, but it still has a 2-foot overhang. So offset 2 feet. From the column this way, from the column that way, and also over here. And fillet those together. again, this would come back and wrap around a bit, but we're just going to carry it to there because we don't need double lines on top of each other. The hip lines are 45 again because it's the same direction. So basically draw intersection to intersection because it's 2 feet in both directions. It'll give you a 45. It'll continue on up. And then it goes underneath the other roof. Dies into the wall there. Actually dies into the siding, but gonna mirror that to the other side. Then we've got the garage, which is another gable roof, 2 feet overhangs. Put these together. And since that is a gable roof at the garage side, here, this is the gable there. We'll have the ridge line at the midpoint. Where those lines go underneath the other roof, they'll be hidden. Then we've got the covered porch. It's 2 feet on 2 sides, and then the one exception to the 2 foot overhangs on the left side of this roof. Again, this actually continues back to the wall underneath there, but we're no reason to draw a double line. Over here, they decided, for who knows why, to make this a 7-inch overhang. I can't tell you a reason other than that's just what they decided to do. I'm talking about on the front elevation. This, I mean, they could have come further out. I mean, they certainly could have come the same 2 feet out, but they decided not to. Not sure why they did it on that side, and that's the only one, but that's the way the designers did it, so that's the way we'll do it. So instead of 2 feet over here, come out 7 inches. So offset 7, and that's from the frame, and then you can connect that. And then that particular one, just like on the other side, it goes back a foot beyond the frame. And you can actually see this line, so we'll keep it in there. However, we need to change it to a hidden line, so I'm going to draw a construction line and change it. So I can get 2 different lines there. Must have matched the wrong one. All right, and then we have the beams that are holding up the porches. What we can do is take that block from the first floor on the overhead layer. So first floor, overhead, not door overhead, just overhead. All right, so I exploded the block on the first floor to be able to do this. So this is explode. I would explode the block. All right, now to get that over to the roof plan, once it's exploded, you don't use the same layer because the first floor layer is the first floor layer and the roof layers are the roof layer. So we need to copy this to a new layer. So in the drop down, there's, I think it's this one, copy objects to new layer. You want to select the beams. At the front and the back. Enter, and then in for name, enter, and then find a roof overhead and say okay, and then enter that again. All right, and then go back and freeze your A1 floor overhead. And it didn't work. Why is that? Oh, because I don't have it thawed. That's why. It was there. I just didn't have the layer thawed. At this point, I think I would go ahead and also set up a separate roof layer state, because you'll have this as a separate drawing anyway. So go back to layer properties and make sure that all the roof layers are actually thawed and turned on, and I would set 0 as current. Of course you have to make sure it's thawed, and then just create another layer state specifically for the roof. So that you can work on that independently as well. So, or you can work on it with other stuff. Because you'll have to go back and add the plate heights and the roof pitches and all that. But this gives us our roof outline. So now we can use this to project down to the elevations to know where the edges of things are. So I'm going to run the second floor, not the second floor plan, but the elevations with the second floor plan. All right, so looking at this, I'm going to go back and set my layer to elevation dark because I'm interested in the elevation now. So we got to begin to read where the first or second floor is. Maybe the X guidelines sometimes are confusing, so you might want to freeze them on occasion just so you don't have to deal with them. All right, so here's our second floor. Here's the edge line of the second floor roof. Here's where the edge line of the gable and the front is. Should be lining up right there, and it is. Here's the ridge line of that front gable. That's good. It's lining up where it's supposed to. Here's the overhang line of that front gable of the second floor. Here's the larger gable that's back behind that overhang. All right, so up here at this roof then, the trim and the fascia board are going to extend on out here. The trim is actually ending there. And then we have, since the trim is a 1x, we need to set the fascia board 3/4 of an inch back. So I'm going to draw a line and then move it back 3/4 of an inch. And that's going to be true of all the fascia boards. Trim board's aligning with the edge of the roof. The trim board at the edge of the house, the fascia would be obscuring what's ever behind it there. And in this particular case, we can know where the height of this is by dropping it off the roof plan because it intersects the roof right there. So where that intersects the roof, that's the height of that ridge line. And so we come back and pull that together. In addition to that, we know where the chimney is now, so we can drop down lines for the chimney. You have to be careful about how you do this because it may or may not be behind a ridge, depending on where it is. In this particular case, it's in front of what we just drew of where the elevation intersected. So it actually would sit on top of the roof here, on this side. This line would be there, but it'd be beyond, so you won't see it in elevation. And then we got to know that the chimney itself is 2 feet higher than the top ridge line here. So we're going to draw a construction line here, offset 24 inches or 2 feet. And then it has a 3.5 inch trim to the inside on both sides, just like the siding does. Go to the inside, go to the inside, clean it up down here where it intersects the roof. This is the top of the chimney, 2 feet above the top of the ridge there. It's also a 3.5 inch trim. Come in down from that. And then this trim runs into that trim. And this trim is wrapping at the top, and since it's a 1x trim, it's going to be 3/4 of an inch out further on both sides. You could offset it or you could just move it. Now let me show you something. Over here, we know this is the end of that gable for the garage. But it doesn't intersect anything but the wall over here. So there's no way we can get a height simply from the roof plan. Next time, not tonight, but next time, I'm going to show you that you can draw the gable on the right side elevation and then project the height back to the front elevation. And then at that point, it really does become like putting together a puzzle, working back and forth between elevations. What you should do at this point is put in the edge line, put in the trim lines, put in the windows, put in the doors, do the roof plan. Then we can go from there. So that's what you should be working on for next time.